Welcome to Study Loop.
This question is a text question. It's got a bunch of pieces to it. Our first question is, this is the phase diagram for SO2. So we've got the phase diagram for sulfur dioxide. And A, what does this diagram tell us about the enthalpy change in SO2L to SO2G? And it tells us that this is, let's see here, I believe that this will be a positive and change. When we look at this, we can see as temp increases, the concentration of SO2 increases, SO2G increases, and SO2L decreases. So that means that SO2L plus heat yields SO2G. So the enthalpy change is positive. Enthalpy is positive. Okay, for part B. Well, let me go find my question. Start going back and forth here. Calculate the equilibrium constant at 100 and 0. Equilibrium constant at 100 degrees and 0 degrees. At 0 degrees and 100 degrees, I think I said. At 100 degrees and 0 degrees. The Kp so at 0 degrees, this will equal my pressure, equilibrium constant will equal my pressure of SO2G at 0 degrees C. So it'll equal about 10 to the minus 1 atmospheres. And at 100 degrees, my Kp will equal my pressure of my SO2G at 100 degrees. And that'll be in the vicinity of 10 to the 1. Very approximate, 100. Or excuse me, 100 is 10. Atmospheres, very, very approximate. Next, let me move down here for C. Why is it not possible to calculate an equilibrium constant between the gas and liquid phases in the supercritical region? Oh, probably because it doesn't exist there. Why is it impossible to calculate K, the equilibrium constant between gas and liquid phases? And the reason here is liquid, let me do this, gas and substance that are dissolved in water are considered for equilibrium constants. In the supercritical zone, no gas truly exists. Okay, D. At which of the 3 points marked in red does SO2 most closely approach ideal behavior? Okay, so at which red point closest to ideal? And remember, we're always closest to ideal at high temp and low pressure. So if we go up here, this is the point that we're closest to ideal. Closest to ideal. Far right point. And let me see, do I have any more here that I need to answer? At which of the 3 points does it behave least ideally? Okay, so let me get back up to my diagram here. Oopsie. And I think it looks like it's going to be that top one. This one will be least ideal. So that's so because it's such a high pressure. So I'll do the highest point. It's got pretty high pressure. As our gas gets less compressible. So I think that should be good.